So I do think that kind of the concept of what big data is controversial because it's a very young buzzword that people have been throwing around lately, and there really is, from what I've seen, no consensus on what the term means. And so, from my perspective, what I would say big data is it's a problem and a potential opportunity for a company. The problem being that perhaps an organization has reached a threshold. There's too much data coming in. The data is coming in too fast. The data is too messy. And with the current state of affairs, the current state of systems or algorithms that a customer has, they no longer can do what it is that they need to be doing with that data in order to run their organization effectively. And along with that, the opportunity being that the more data that a company collects, the more opportunity there is for analysis of that data, for predictions in that data, for identifying correlations and thus. And so the opportunity can only be realized if the kind of the methods or technologies are in place to be able to effectively analyze that data. That would be my definition of big data.
Great. Anybody else on our panel want to have a different discussion about that? Or we could just move on from here and actually talk about, when we're talking about the current state, we see this particular terminology quite a bit. If you guys read any of the O'Reilly or some of the GigaOM articles, a lot of times they're talking about the 3 V's: volume, velocity, and variety. I'd like to open it up to the gentlemen here if they could chat to these specific points, what they mean as they relate to big data. From an English standpoint, I know what those terminologies mean, but when it relates to actually what it means to big data, I kind of get a little lost in the clouds. So if you guys could help define it, it'd be great.
So what I kind of see big data as is a paradigm shift in the way that we're a good predictor of whether or not a problem is big data or not is what paradigm you're using to analyze your data to get at the results and what types of algorithms are being used. So some of the technologies that are out there, we can talk about it in a little while. But if we look at volume, normally you'll reach this threshold and have to get to a new technology. Instead of regular relational databases, you go to a NoSQL or HDFS or something similar. But the volume usually gets at terabytes and petabytes is usually where we see that happening. The velocity has to do with how fast the data is coming in. If you're looking at stock market ticker symbols and like the price going every second or whatever. And then variety, we often look at structured versus unstructured data, where unstructured is usually prose or just streams from the internet, where you're just getting anything in any format.
Great. And that kind of brings us to that last point, to the variety of it all. Let's further define structured versus unstructured data, right? Because I was recently at the Mass TLC Big Data Conference up in Cambridge up there, great gathering. A lot of different opinions still as to what's the best approach in this space. But a lot of the talk was also around what is structured versus unstructured. If we could highly define that for the audience, that'd be great.
So structured usually is a densely populated database, and then unstructured can be anything from photos to prose or just content on the internet.
Something I was thinking about, a good example is, or maybe it's a positive way to define it, is someone's out at 2 a.m., they're snagging a couple of photos on their cell phone, they've had a few drinks, and all of a sudden those photos are living on Twitter, Facebook, they're out on Instagram, and they're being generated from one individual's cell phone. Where does that fall? Is that structured because it's going off to platforms that have a way of defining it, or is it unstructured because it's completely unique to that moment in time? Like how do you place that data?
So the way I'd like to think about it is usually like the metadata and kind of the timestamp and that and who took it, location can all be in the structured sense or in the structured category, where Facebook or Flickr or something would take the metadata and put that in their big database, and then the unstructured would be the photo itself and content like the notes around it or whatever the person said.
Another example of it might be that you might see more frequently in the business realm too, is to speak to what Mike was talking about with opportunity, where a client may have many years of spreadsheet-based data on lots, literally thousands or tens of thousands of spreadsheets. Aggregated, this data might be useful and helpful in predictive analytics. Standing alone, it's very unstructured. So there's a preparation exercise that can turn legacy into big data as well.
From my perspective, this is a pretty important point because I think where the real gold in big data comes from, in the big data, the ability to effectively analyze big data is with unstructured data that's out there. The vast majority of information that's available that might be pertinent to a situation or might be able to correlate to organizational data is unstructured data. It's data that exists on websites or in books or historical data patterns, and being able to effectively structure data, whether it's through a transformational process or whether it's through coming up with algorithms that can effectively process unstructured data, that is a challenge that needs to be addressed to really get the benefits of big data.
Oh, perfect. So really, if you're talking big data, there's that 10,000-pound elephant in the room that is known as Hadoop, right? And you really can't get around it. Everybody's talking about Hadoop and the challenges with it and the benefits of it. So we thought it'd be nice to just explain, at least briefly, explain this infographic that we were able to snag from online and explain what's actually being visualized for us here. So Bill, I think you wanted to walk through some of this.
Sure. So starting in the bottom left, you have the data and where you're starting, and then in the top right, you have kind of the results and what you want to get from it. So applications, apps, business intelligence, visualization of the data, and actually the results of what you want to get. In the center bottom, you see the big data Hadoop and HDFS Hadoop distributed file system. MapReduce. This is how the data is stored and then processed, and then above it is how you kind of do the more analytics to it. So Mahout is a good machine learning Apache open source, similar to Hadoop, but for the machine learning side of things. So that'll get you the analytics, and then that brings you over to the top right where you have the output, which is the out and the visualization.
Great. So we see so much of Hadoop out there, so I guess the question to ask is it the only solution that's out there? And we just have this little cute graphic there, and the answer is, of course, that the answer is no.
Just one other thing on Hadoop. So it's an open source from Apache, a MapReduce architecture. MapReduce being the white paper that Google put out about 10 years ago now. Which is a massive. It's for massively parallel, making massively parallel computations on commoditized servers. So not big supercomputers, but on regular servers that can be all over the place, and then making it massively parallel so that you can do this kind of processing on terabytes and petabytes of data.
Great. And again, just to the point, there are other options out there. Like obviously, IBM has put a boatload of money and time into mastering and getting value out of Hadoop. But again, we were at a specific conference just last week, and there were others from many different organizations saying, there's a lot of ways to tackle what is the greater space of big data. Is there anything we want to say about some of the differences and variances that do exist?
Yeah, so not necessarily on this list, but something that we learned about was that some people are looking into array-based database models. So when you go into multiple dimensions, 2 and 3 dimensions, or higher than 3 dimensions, but it's easier to understand at 2. When you're looking at a matrix and you have the four items in a square, they would be close to each other in memory if you use an array-based database model as opposed to a single dimensional array where they would be very far from each other because you have to actually flatten the matrix into a single line, so they would be farther away. And then that's also true about a lot of relational databases. So there are other ways to skin this cat and ways to look at it.
Clinton, one other way of looking at this is the way TopCoder has been addressing these problems recently as they come up. While there all these wonderful technologies out there, there are also classic techniques in machine learning, in supervised learning and things of that kind that have proven effective as well, particularly on the spreadsheet help problems. Once you're able to aggregate that data, you can start asking really useful questions. And that really gets into enabling, really finding potential in this data that may have just been captured en route to another task. Maybe it was in a spreadsheet because someone was in a field. Maybe these are audit logs that no one really knew what to do with. So by applying ML techniques in our marathon matches, we've been able to derive really useful, really actionable business data out of these things.
So again, what we have today is one of the better examples of technologies, the Mahout or Mahout, pronounced, I don't know either way, but that's for supervised, unsupervised learning. And machine learning here usually implies self-improving algorithms. As new data comes in, you can get better results. On the actuarial science piece, so we can look into insurance pricing decisions and figure out where to come up with how to price out models based on past data and predictive modeling and stuff like that. So that's another good one. So what we're saying is a really important point is that this goes way, we're talking about machine learning, actuarial science. This is way beyond flipping emails for quick cash. So it's not taking the data by itself and then just selling it off. What we're doing is doing bigger and better things with it, which is where the real value is coming in.
Yeah, I think that's an important point to make is, a lot of people, from what I've seen when talking to them about big data and what their organization can do with big data and the big data issues that they have is, when people think about monetizing their data, the majority of companies seem to think that's all about selling their data, like what Bill said, flipping your emails for cash, and that's not the case. There's so much data that can be collected now across all organizations, across all industries, that the data itself is becoming much more valuable than the possible retail value of the data, which is even much more controversial anyway.
I think as somebody said, don't sell the gems if you can sell the jewelry, right? So process it and get something valuable out of it, and then be able to sell that or increase your bottom line from that. So
great points there, Andy. Anything you want to add?
Yeah, and another aspect of all this is we're kind of talking about big data as though it always and must be a deliberate push that requires a specific investment, and you're going to go do this data mining. In my experience, it isn't always my experience with our clients so far, this isn't always the case. A line of investigation may begin with a standard enterprise project. You've got a database, you have a relational database, you have a data warehouse, and you're trying to build reports on these things. But you're finding that as well as it answers some questions, it can't answer other questions well enough, and yet the data seems to be able to support these questions you might want to ask. Think questions like how often, if this happens, will that happen as well, and you can't really program to that. That's when the being able to run an ad hoc machine learning task, a contest if you're doing it through TopCoder, has been really helpful, and it's where it's been able to open up a whole new line of big data questioning. So kind of implicit in all this is having, as they say in sports, having your head on a swivel, to see when you're able to start asking these more impactful questions.
So when we look at the near future here, what will be affected, it's really all-encompassing, and that's part of what we want to get across today, at least from a macro standpoint, is if you don't think it's important to your industry, you're wrong. You're wrong, and you might be very wrong depending on what industry you have to be in as well. Anybody from our panel want to talk on any of the specifics within there, or put a fine point on any of the particular examples that are in that circle?
Yeah, so I think social was one that could have been on the survey, but that's another really important one. But I wanted to speak on healthcare for a bit, just because obviously that was So a big thing there is kind of the holy grail of predicting morbidity, mortality, and then obviously preventing that and kind of diagnosing and treating using past medical records, electronic medical records, and all that. So that's kind of the big example and the big take home for healthcare. I think government is here, and I think we're going to see an example of that coming up. So,
Great.
Government's huge in that the data being collected by government, in many cases, it's a public data set. And, other organizations collecting data outside of maybe your core industry just provide even that much more value, because trying to find the correlations across not just things happening within your company, but things happening external to your company can add to the potential for an extreme value outcome in terms of being able to predict things that will be effective for your company.
Very good. So I want to just run through a few of these that are like more, again, maybe the next 18, 36 months we'll see them blossoming more and more. This is already taking place. This was happened to be in Santa Barbara, California. I know the NYPD is also doing quite a bit in big data, predictive analytics. But this particular example is their PD department gauging crime, gauging hotspots for crime, and then literally placing officers where they think they're going to need them based on real-time and near real-time data and instances that are actually occurring. So quite a leap from where we stand today. And as more police departments take hold of this, it can be remarkably powerful. Anything you guys want to add to the specific predictive analysis place, or?
Well, I mean, I'm not sure. I'm jumping ahead of myself a bit, but I mean the role of innovation in predictive analytics is huge, and TopCoder is in that place right now. TopCoder is a company that runs challenges and competitions along the whole spectrum of software development, algorithms included. And one of the things that we've seen is a strong point of using a diverse international body of mathematicians and algorithmists looking for predictability in the data is just the huge breadth of techniques that come to the table that you might not have access to if you try to do this in-house or individually or using that guy that sits in the corner that knows statistics or whatever. It's really a whole new ballgame. And that's, I think, something that's innovation in predictability is going to have to be embraced.
Perfect. And so I just want to bring a couple more examples to light that really just, again, hammer home the point that if you don't think it affects you, well, it does, right? So this, for instance, is a connected toothbrush. You might say, what the heck do I need a connected toothbrush for? Well, it's going to be attached to an application. The app will bring value to an end user. The data will be sent to dentists. It will monitor. You literally monitor your hygiene, and of course it's going to get better and better and more advanced. So it goes down to individual consumption of what normally was being consumed by only healthcare companies, only Wall Street companies. Now it's going down to individual bathrooms and then back to places like healthcare. So it's where it originates, it's where it creates value with an end user, and then where it ties back into traditional systems like in healthcare and things of that nature. So I just want to bring that as a point. I'll filter through a couple more very, very quickly that are in that connected sensor realm. This little black box is not the board from TNG. It kind of looks like it, but it actually will seek out heat in your house, find the hottest spots, take the heat, and literally crawl over to the cold spots and disperse the heat. Again, this is a machine that is learning on its own, and it's also basically improving an individual's life and just operating in an autonomous fashion. Finally, the self-quantification realm, how to optimize your caffeine through applications, and a smartphone app that can get you out of depression. It's sensing if you're not moving on a couch. It's reading your data, like who you calling, who you texting. Are you talking to nobody? Have you not moved in the last 6 hours and you're not sleeping because it can tell if you're sleeping? Well, a bout of depression might be just around the corner, and now an application is going to ping you with something that goes to you to nudge a specific user to do something that would get them out of what could potentially be a bout of depression. Again, it is far-reaching, and you have to just start to think, how can this data be applied? It's pretty remarkable. So we kind of flew through those with purpose because I wanted to just take a step back and say, the audience out there, did you notice where the conversation went to? We're no longer talking about warehousing, right? We're not talking about those things. We're talking about, and this was pulled from a GigaOM article very recently, you could extrapolate or juxtapose what they're saying about Hadoop here and put in instead the greater big data realm. And really the value is on the applications and the algorithms that will be based in big data, because it's value created on top of it or with it. That is really where you guys ought to focus, because that's, again, that's where the value creation will stand. Can you guys put a finer point on that, or make it sound a little more intelligent than what I just said?
Well, I mean, I completely agree with you, Clinton. I mean, it's that, you know, we've all seen glimpses of the future. We're on the cusp. You know, I guess everybody's always on the cusp of the future, but it seems pretty exciting, the point that we're on. And you see that we're at the point where we have individual devices, micro devices. Everybody has cell phones and PDAs, and you know, now refrigerators have computer chips, and they're talking to grocery stores. Everything's talking to everything else, and that generates huge amounts of data. And so it's not just an issue of how do I deal with that data. There's, you know, how do I create bigger internet bandwidth, or you know, or store all this data, or how do I create enough storage space to store it. But it's about how can I analyze that data real time? How can I utilize all that data that's coming in to better perform in the other areas of my company, or to, you know, like I keep going back to prediction, to better predict based on patterns that are currently happening what's going to happen in the future. And it's those algorithms that can do real-time analytics on the increasing volume of data across everything that are going to add value, lots and lots of value in the future.
Great.
And putting another angle, Bitch, on what Mike is saying, it's one thing to have the horsepower to be able to do this kind of analytics, but you need to be able to couple it to an innovation channel that can do something with it. You probably won't be able to just go down a single path. You may not even see the path you need to take in the beginning. It's more powerful to be able to try several paths at the same time and see where it really takes you.
So I think some of where the main value can come in, like just some examples of some like big data kind of problems and stuff. Customer retention, if you look at like almost like many companies, but you know, software as a service where you're kind of even looking at subscription rates and stuff, looking at when is somebody going to quit the subscription or cancel something. You can look at all the prediction data from the past to try and figure that out. Compression of images for sites like Flickr. If you look at how much data they have there, that's mind-boggling. But and then like search rankings for kind of natural language, trying to figure out. I mean, obviously that's where it all came from, is the MapReduce from Google. So.
Great. And Andy, I think you wanted to chime in as well.
Yeah, another one is testing assumptions. You know, you assume, you know, you've got a product, you're selling it a certain way, and you assume that's the right way to do it. But sometimes, you know, drilling into your own data can help you find new relationships between, you know, sales or returns even, and the type of campaigning you're doing. And that's another thing that's sometimes it has been so far been an unexpected outcome of mining your old spreadsheet data.
Great. And Mike, I think you wanted to add one as well.
Yeah, I just wanted to point out that, you know, that this is a great slide to point out that it doesn't have to be, you know, getting value out of big data analysis doesn't have to be the whole circle or the whole cycle. So just looking at improve, you know, just improving an algorithm that is processing your real-time data to be able to accommodate, you know, 4 times more data. You know, just that in itself, you know, however you go about doing that improvement, whether it's through an innovative process or a competitive crowdsourcing process, or by utilizing, you know, resources internally, you know, that's valuable. It doesn't have to be the value from big data, or the value in approaching the big data problem can be simply in just you know, coming up with new mathematical techniques or whatever to improve the speed of existing algorithms.
Great, thanks.
Guys, hey, it's Andy again. Sorry, quick question. Mike, to what extent do you think that plays into velocity? And so if you have data coming in real fast, you know, how much of being able to handle it is simply having the speed to be able to process some of that stuff real time?
Yeah, I mean, addressing the velocity problem is all improving algorithms, either improving or fundamentally inventing new types of algorithms to process that data. And that's a very important aspect, because, you know, access to really high-end mathematical and algorithmic talent it's hard to come by. And so aligning yourselves with a way to tap into that talent is important. I've seen in a number of cases extreme value outcome in action, and it can never be predicted or expected, ironically, when we're talking about the potential of prediction. But it's, you know, it justifies or it has the potential to justify an extreme expenditure on an open innovation approach when you get a couple of extreme value outcomes in series, because it's really what we're talking about is a fundamental breakthrough or orders of magnitude improvement over something that you might have thought, from a performance standpoint or from an accuracy or predictiveness of an algorithm, something that you might have thought was the best that could be done. And it's just so, once again, important to get a lot of heads looking at a problem like that if you're looking to get that extreme value outcome. And a competitive, crowdsourced approach to that is the best way to get extreme value outcome.
So this is really a TopCoder specific thing. We can't speak to other communities or how other communities who do open innovation share knowledge throughout, but we can say in the TopCoder world and in our realm, there's a whole heck of a lot of collaboration. They do compete as individuals most often. We have some things where there's teams, but most often it's individual competitors. But when the bell rings or when the match is over, there's a whole lot of discussion and a whole lot of transparency of how did somebody derive a best solution? How did they get to that endpoint that beat somebody else? And what happens is the person who lost just got a lot smarter. And guess what happens? Next time they go out and compete, well, they compete a little bit better. And it's just this kind of a virtuous cycle that we see, and we've seen that really from the onset. But do you guys want to talk about anything specific there, or should we move on to some of the other pieces?
Just real quick, I'll say that creating a community with those dynamics is very, very difficult. A community that's competitive by nature and willing to be collaborative inherently, it's so important to discovery and to advancement and getting things done. That it should be a primary focus for any sort of an initiative for open innovation.
Great, thank you.
And to sharpen it on a point, I can say that in some of the clients that I work with, the feedback from the community members after the contest is run have directly led to decisions that the client makes based on that feedback. So it's opened up a new contest series, it's changed how they think about their own data, and it's given them new ways of correcting long-standing problems.
Next one is this near-field expertise can really spur innovation. And so what does this mean? Defining it very quickly, we've got a whole community of competitors, and they may be great in certain disciplines and certain domains, but they don't have exact experience or sometimes no experience, like any experience, in a specific thing that they're going to try and compete on. But what we see happening quite a bit is something they learned while mastering something else is highly applicable to what they're doing in a different domain or a different discipline. They bring those skills, that near skill, bring it to a different domain, and that also brings in, it really is a catalyst for new ideas, new creation, and new ways of looking at not just solving, but defining a problem, and then providing a solution for it. This last one is, of course, really about cultures. This kind of hits on all the ones we just talked about, where when you have, again, TopCoder has over 200 countries within our near 400,000 person community. So you've got cultural differences, and these add up, because there's a famous Einstein quote, and just paraphrasing it here, that if he had an hour to save the world, he'd spend 59 minutes defining the problem and a minute going after the solution. When you've got hundreds of people, or sometimes it can be even higher, going after a particular, looking to define a problem and then go solve it, you're just bringing in unique life perspectives that just cannot be overlooked. And the results are, going back to the first key, you do get those extreme value outliers, which is really what you're after. But some of the reasons that it does exist. So I'd love to get to some of the TopCoder examples, because we are getting a little slim on time here. So we'll talk about some real-world examples right now. One thing that some of you on the call may know about and some may not know about is an initiative with TopCoder and NASA and a couple other partners called the NTL, or NASA Tournament Lab. And I'll just hand the baton to Mike on this because he knows a great deal about the particular NTL and also some of the challenges we're running within it.
Thanks, Clinton. And I'm going to make this real brief just because I want to be able to get to some of the other examples, and I know we're running low on time. And so the NASA Tournament Lab is a partnership between TopCoder, Harvard Business School, and NASA as a way to get difficult and challenging algorithmic problems solved for NASA researchers and scientists through open innovation. And over the past 6 months or so, we've run a number of challenges for various departments of NASA, and one such example is a crater detection problem that we ran. So NASA was interested algorithmically identifying areas of imagery, millions and millions of images of the moon and Mars, and figuring out which of those images contain craters, because they don't want people to have to go through all those images and trying to determine that on their own. And so we set up a competition that we ran for our member base. It was an algorithmic competition in which competitors had to submit programming code and try to determine in these images, the likelihood that an image contained a crater and the location or the coordinates of the crater. And it was very, very successful for NASA. They were, really happy with the results. And this was definitely an approach for identifying a big data problem. NASA had, the imagery, the quantity of the imagery is just increasing as more and more probes go up into the solar system, taking more and more pictures, and more instruments are sending data back to the Earth. So that's just a great example of how the NASA Tournament Lab has been used to approach a big data problem.
So genetics offer an obvious big data problem. A single gene is absolutely gigantic. So we're able to help in a couple spots here. One is innovating solutions that can sequence genes computationally in a different way, and another one speaks directly to the velocity problem, where we have clients who have genome problems that take sometimes 10, 15 minutes, and we've been effective at reducing those down to milliseconds instead. Like Mike said before, the skills involved in making that change are rare. So it's a huge part of getting off on the journey towards big data and analytics to speed it up.
On optimization, we had done something similar with NASA again, sorry Andy, but we did a medical kit type of problem where on the space station you care about the astronauts' health, and you have to keep them as healthy as possible for as long as possible, but you have limited mass and volume. So what you're looking to do is kind of make trade-offs between, should I bring Band-Aids or Neosporin, should I bring Motrin or another pain medication, right? So they make the trade-offs to try and figure that stuff out. And Mike can probably speak to the success of that one. Sure.
Yeah, well, there's no better way to describe the success than to say that the algorithms, the top 5 algorithms that came out of that problem were combined, and that algorithmic technique has been incorporated into NASA's medical kit planning software that they utilize now for future space missions.
One other aspect, Andy, I think you could talk to this best, is just the idea of going after bigger questions in big data, right? And for those who are interested, I definitely encourage you to go check out that video online. But Andy, you've experienced this a little bit lately, and can you just tell the audience what this entails and what's the importance of getting beyond kind of the obvious questions and going after ones that maybe you just haven't thought of yet?
Some of it has to do with just having fresh eyes on a problem. So when you have a large community of people with these exemplary skills and a great deal of creativity, they have the curiosity and so on that led them to learning these things in the first place, they can notice patterns that you may not have seen before. Some of them come up organically on their own in post-contest analysis. Others are solicited more directly through idea generation contests that we've been posting. But by doing this, it helps people who are accustomed to looking at data in one way in an entirely new way. So it also can help them chain along or connect the dots from capabilities that they knew they had to outlets that they didn't know that they had in new media, in mobile platforms, social platforms, and things like that. So we're finding that that's been instrumental, all the way up and down from the more traditional, here are some very basic marketing questions you could be asking, to the less traditional and more cutting edge. Did you know that you could hook this plant up to Twitter? That kind of thing.
Just wrapping things up, right, there were 3 things we talked about: the current state, where this is going in the near future, and then why open innovation and the competition models have a unique role to play in big data. So starting with, Hadoop is huge. It cannot be ignored, but there are alternatives, and people are seeking alternatives that are out there and wanting to understand what they can do on top of it. And that kind of brings us to point number 2. It's not the size specifically. It's not just the volume of the data. It's what you do with it. It's what you create with it. It's the patterns you recognize. It's the visualization implications. It's how you deliver these things to end users through even individual mobile applications that, again, assuage behaviors, create new value, discern a new pattern that can help a government make better decisions. So there's value to be had. It's really across the board, but you have to start thinking about this in a brand new light. And finally, we did talk about that really open innovation is just an exceptional way to create value in this space, because you get to take a lot of swings. You get to have lots of minds on these things. You get different cultures defining problems and finding solutions for you. And really, the final point is the value that is being created, the extreme value outcomes that are being created are just the proof in the pudding.